Okay, so we are looking at day 2 here. What day 2 is brings in day 1 stuff, and this is basically what we've been doing the last about 3 days, Wednesday, Thursday, Friday. So let's go through and take a look at what we were talking about real quick. Okay, to be a function, all right, when a relation is a function, we need to have unique x values. So I'm just going to throw in some x values here. And for the y values, or the f of x values, y and f of x is the same thing, all right? That doesn't really matter as much. I got to make sure the x values are all unique. So if I try one that is not a function, okay, I can see I had written up something with two x values. Now here, when I go through and write out some y values, 4 cannot be going to 7 and 4 going to 8 at the same time. That is when we consider a relation not to be a function. So 4 cannot go to 7 and go to 8 at the same time. That's when things mess up. So that's from a table values viewpoint. From a graph viewpoint, it passes the vertical line test, we call. So examples of a relation that is a function is V-shaped. It could be U-shaped, various U's. It could be just a line. It could be kind of just a squiggle. Now, all these that I've been drawing are doing what we call is passing the vertical line test. Now, what do I mean by the vertical line test? Literally take a vertical line, take your finger, and as you drag this line across the graph, I can only have that graph hit the vertical line at one point at a time. And as I drag this thing across, I can see that this is hitting it at one point at a time. And then what that means then is I have myself a relation. And essentially that's what's happening up on the table as well, that there is not an x value that is going to two different y value locations. Now for it to not be a function, let me try something like this. Make it a little bit better circle. There we go. So here, this is considered to be not a function. And the reason why on that is, as I drag it across, it just screws up all throughout. As you can see here, it is messing all throughout here, where it's hitting the hitting that vertical line at more than 1 point, 2 points actually each time. So this is what we would consider is to be not a function. If I was to take the point 2, comma 4, and 2 also goes to like negative 3.5. That cannot happen. That's why we call it a not a function. And there's an infinite amount of possibilities of that. We can put something like this up there. We can have a graph that kind of doubles back on itself. And as you can see right here, it's fine 1 point at a time, but then right here is where it messes up, and this is then not a function. Now, number 2, A and B, look very similar to a table, not quite, but a table. We call this a mapping diagram for letter A. Same idea as holding. P, Q, R, M, N are all different values, and this is one we are considered to be a function. Now, how this is not a function, let's say P was also going to N. Since P was also going to N and going to M, that would be considered to be not a function. But because we don't have that, that is then a function. Letter B, you got a vertical line. I know it sounds kind of weird here, but I'm about to take my vertical line test again. Anytime I see a graph, I'm going to do the vertical line test. And as I drag that across, so I can get my formatting correct, it messes up, well, right on top of the line. That vertical line, okay, that vertical graph is made up of a series of infinite amount of vertical points one on top of each other. So when I draw that vertical line on top of it, that is not a function. Now for number 3, we want to determine if they're functions or not, and then we're going to come around and do the domain and range. And this is what we had done on the first day of things. So this is, like I said, kind of a just nice pull together everything. And then it's just really practice after that. Domain and range is also going to bring in my interval notation that we had talked about from Tuesday. First off, number 3, this is passing my vertical line test as I drag that line across, okay? It is passing the vertical line test. It's a function, 1 point at a time. It's all cool. So we say it's a function. Now the domain, that is the x values. So what I mean by that is, in order to make that U-shaped graph, you have to ask yourself, what x values do I need in order to make that graph? So you have an infinite amount of x values out there. And you don't want to be greedy and only take the amount of x values needed to make this specific graph. So the x's are read from left to right. Now the thing about this graph is, just like we did with the inequality work the other day, that as you can see, we have arrows, and this graph continues to open down, and it also continues to open out to the left to the negatives forever. So what that means then is, this graph is going to start way out there at negative infinity. And then as I read that graph from left to right, okay, so I'm way out here at negative infinity, that graph is being made. As I come closer back to the origin, my graph then continues to the right and down. Because it's continuing to the right forever, this thing is also going then to positive infinity. So as we go to infinities, as we learn from interval notation, we always use a parentheses. Now the range is y values, and I like to say bottoms up here because we are looking from the bottom up. This graph is starting way down here at negative infinity. My graph is way down here at negative infinity. And as my eyes start to go up, my graph continues to go up from negative infinity all the way up to, and then it stops. And what I like to then say is I hit a ceiling right up here at a y value of 4. So my range is from the negative infinity all the way up to a y value of 4. Now I use a bracket at 4 because that graph where I stopped at, that ceiling, is all solid right there. And solid means I get myself a bracket. So the y value is not using every number in existence. It only needs to go from negative infinity up to 4. Now letter B, we said, is not a function. And the reason why it is going to be not a function, again, is it fails the vertical line test. The domains, now again, I don't need every x value in existence for a circle to be made here. I only need from this negative 6 over to this positive 4. So from negative 6 to 4 is going to be my domain. I don't need to go past negative 6. I don't need to go past 4. And I'm putting brackets there because that graph at negative 6 and 4 of those x's, it is all solid. For the range, I don't need to go way down to negative infinity to see where this graph starts. I just need to look down here at negative 5, and I need to just stop up here at a positive 5. So the y values that are needed to make that graph are from negative 5 to 5. And because it is solid, I'm using my brackets. And for this last one, letter C, it is also also not a function because it fails my vertical line test all right along here. Now here, my domain for the x's, I will use everything because that arrow tells me continue to go out forever and ever and ever and ever and ever and ever and ever and ever. My graph starts way out there at negative infinity. From left to right, this arrow tells me to make my graph continue to go out also to the right forever and ever and ever and ever and ever. So I need from negative infinity to positive infinity in order to make that graph from left to right. Now vertically on the range, bottoms up, what I can see is it is stopping right there at that y value. I don't need to go way down there to negative infinity. So that y value is, what value is that? 1, 2, 3, 4, 5, 6, 7. Let's get a y value of 7. So I only need to go down to 7. And then I only need to go up to 1, 2, 3, 4, 5. I only need to go up to 5. Because I only need to go up to 5, all right, our range is from negative 7 to 5, brackets, because that graph is solid on both sides, okay, on the top and the bottom. And that is how we do domain and range. Now the practice that is on there for tonight has a lot more practice there, answer key. If you need more help, just give me a holler.